Good afternoon, everyone, and welcome to today's Knowledge Bank. Today's Knowledge Bank is being presented by Daniel Snape, Associate Director from Watts Group. If you have any questions throughout the webinar today, then please submit them in the Q&A box, which is at the bottom of your screen, and we will try to get through as many as possible at the end of the webinar. Today's webinar is also being recorded and will be available to watch back on the News on the Block YouTube channel. That is all from me, and I am now going to hand you over to Daniel to begin.
Excellent. Thank you very much, Vicky, and good afternoon, everyone. Thank you for joining the latest Knowledge Bank. As mentioned by Vicky, my name is Daniel Snape. I am an Associate Director at Watts Group and a Chartered Building Surveyor. So today's session is going to be on an introduction to facades. So we're going to look at the design of facades, some of the common systems in use in residential property in the UK at the moment. We're going to look at some of the common defects associated with those facade systems. And then we're going to look at the sort of general maintenance, so best practice tips for maintenance and how to ensure basically a successful procurement and project sort of process. So starting off with the agenda for today's session, I'm firstly quickly just going to touch base on so who we are and what we do. We're then going to jump into the importance of facades before having a look at the overview of the common facade types in use at the moment. We'll then have a look at defects, so some of the common defects, the importance of conducting routine inspections and maintenance. And then before a Q&A session, we'll have a look at some best tips for procuring repairs and maintenance. So starting off with us, so who are we? So at Watts, our tagline is powered by our people. And what that really means is that we have an excellent team of knowledgeable and experienced people. And it's those people really that make our business great and give us the reputation that we've got. So we're property and construction specialists working nationally to deliver increased value across all asset classes within the public and the private sectors. We have offices in 7 locations across the UK, as seen on the map there. So this enables us to serve all areas effectively. And we provide a number of core services. So the first core service is building surveying. So what does this include? This really includes building inspections, looking at defects and diagnosing those defects, undertaking planned preventative maintenance schedules, undertaking technical reviews for licenses to alter and sort of supporting that process through. We also do a lot of dilapidations, contract admin work, and preparing sort of designs and specifications. That's kind of a blanket summary, but in reality, we do sort of a fair more other things, sort of EWS1 support, etc. The part of our core services is cost management. So our cost management team basically ensures that clients are obtaining value for money and that projects are being completed on budget. We can also provide independent reviews to ensure quotes or tender returns received are reflective of market rates, and again ensuring that clients obtain value for money. We also have an independent monitoring team. So this team provides independent monitoring for a range of stakeholders to ensure that projects are progressing as planned in line with the contract specification and that correct payment processes are being maintained. Moving on to project management. So we have a team that's familiar with various forms of contracts really and is experienced in procuring and delivering projects through all the REBA stages from minor to major works and across all sectors. Last but not least, we have a public sector team. So we have a nationwide network of public sector specialists that hold established relationships really and framework agreements with both national, local and publicly funded bodies. So moving on to the topic of today then, so what is the purpose and the objectives of this webinar? Well, as block managers and professionals operating in the residential built environment, you all play a really important role in the care and maintenance of buildings and the general health and safety of residents. You also have quite an important responsibility to ensure your building doesn't cause harm to members of the public. So this webinar really focuses on one of the most important elements of a building, and that's the facade. And personally, I believe it's important that individuals with responsibility, such as yourselves, have a sort of a good understanding of the basic design principles of their building's facade and some of the common defects associated with those different systems. It's also good to know the advantages and disadvantages of common systems to support informed decisions being made. So by the end of this webinar, I'm really hoping that you'll have gained a basic knowledge on the importance of facades, the different types of facade systems commonly used and their basic design principles, some of the common defects associated with those different systems and how often they should be inspected. And then last but not least, just some considerations for the procurement of repair works. So why are facades so important? Well, the obvious reason is they provide the first line of defence between the interior of a building and the external environment. A facade essentially acts as a barrier. It provides a comfortable internal environment and protects everyone that uses that building from the external elements. Facades are also one of the areas of a building which is most prone to failure. So they must constantly withstand the effects of the external environment, and they're subject to movement throughout their lifespan. Another important factor is that facades have a major influence over the thermal performance of a building. So they can contribute significantly towards a building's EPC rating, and they're often designed to help achieve sustainability targets. Perhaps the hottest topic of the industry, or one of the hottest topics at the moment, is fire safety. And facades are really an area of key risk in relation to fire safety. Their design can either reduce or prevent or accelerate the movement of fire throughout a building. Another key reason is that facades, another key reason is that, and perhaps one of the most important reasons to block management, is that facade repairs can be very, very expensive, and works can cause significant disruption to tenants, and potentially in some instances even temporarily prevent them from occupying their demise. In addition to that, some of the other key reasons are that facades often form the character of a building. They're there for aesthetic purposes. So I'm sure we've all been guilty at some point in the past of judging a book by its cover. And really the same can be said for buildings. Everyone wants a good looking building. So it's important that it's maintained well and it, keeps up its visual purposes. And last but not least, a facade actually forms one of the most expensive packages of a building. In fact, this can be up to 35% of the overall construction cost. So it makes sense to take good care of it. So moving on to the first sort of main section, we're going to have a look at some of the most common types of facades currently in use in residential properties, and we'll explore some of the key advantages and disadvantages of those facade systems. So let's start with traditional brick masonry. So this is a traditional form of construction which has been used for centuries in UK construction. Now, when we say the word facade, a lot of people think of curtain walling or large spans of glazing, but actually a facade is just what forms the envelope, and it can be constructed of brick. So what are some of the key advantages to brick masonry, and why has it been used so often over the decades? Well, one of the main advantages of masonry is that it's durable. So when correctly constructed and maintained, it can last for decades. Brick also has a very good resistance to fire and infestation. Obviously, another reason why it's commonly used in UK construction. It also provides excellent acoustic performance, which can often omit the requirement for further acoustic treatment, such as internal linings, but of course that need can depend on the local environment. And generally, brick is also popular because it's considered low maintenance. So inspections can be relatively easy to undertake in comparison to some other forms of construction. And repairs are typically required at wider intervals compared to some other forms as well. And then last but not least, brick is actually considered to be a fairly sustainable form of construction. So bricks can be reused, old bricks can be recycled into new bricks, and as mentioned, they can last hundreds of years. Production processes actually are also becoming more efficient as well. So generally bricks are considered a fairly sustainable way of constructing a building. So now that we've looked at some of the advantages, let's have a look at some of the disadvantages. So firstly, brick generally has poor tensile strength, what that means is that seismic activity and thermal movement can result in cracks, which can lead to a host of issues, some of which we'll explore slightly later on in this webinar. It's also porous. This means that water saturates through the brickwork partially, and in older buildings formed of solid walls, this can lead to sort of fairly considerable damp issues. Another disadvantage of brick is that it's time consuming to construct in comparison to some other forms of construction. This can result in higher labour costs and generally a longer programme on site. Adding to that, I guess, there is a disadvantage that weather can often prohibit the construction of masonry. So poor weather can limit construction, further adding to increased time on site during the construction period. Internal finishing works are also something that's typically required with brick, and is something that can quite often be overlooked in construction. So other forms of construction and facades may include an internal lining from factory. However, brick typically requires an internal layer of plaster or decoration to complete, again adding to construction costs. Last but not least, brickwork's pretty difficult to clean when it hasn't been painted. So I'm sure some of the people on this call may have experienced graffiti to their buildings before and how frustrating it can be. Well, cleaning brickwork isn't the easiest of tasks. It can be time consuming and can cost a fair bit of money. So something that I wanted to move on to next was brick slip systems, which isn't sort of a traditional form of construction, but it is something that's becoming more and more common in residential property. So in this slide, I want to focus on mechanically fixed brick slip systems before moving on to adhesive-based brick slip systems. So the image on the left basically shows a partially constructed brick slip elevation. So this image is a good example of how modern brick slips are designed to look almost identical to traditional masonry when completed. So in that image, obviously it's partially completed, mortar hasn't been applied to any of the joints. But at that point, an untrained eye and from non-close viewing would probably find it quite difficult to tell the difference between a traditionally constructed brick wall and brick slip systems. So let's take a look at the typical basic detailing of a brick slip system. So looking at the image on the right, insulation panels are fixed to a substrate. Now this could be blockwork, it could be cement board, it could be timber or metal. Insulation typically comprising of mineral wool or some other materials is then fixed to that substrate before carrier rails are then installed to enable a backing plate, as seen here, of the grey plate, which then allows the brick slips to actually be mechanically fixed. In this instance, they're clipped into place via these backing plates, which are designed to include rails that space the slips correctly. So this system basically is basically finished by manually pointing the gaps with a suitable mortar. Now, one of the main advantages of this system, which is why it's becoming ever more common, is that it's quite a quick form of construction. It also mitigates some of the weather limitations of traditional brick construction. And I personally think that this is going to be something that we're going to see more and more of as construction develops through time. So let's move on to bonded brick slip systems, which, as seen in the left image, involves securing brick slips in place via an adhesive. So I think it's important to note the warning symbols that I've put either side of adhesive-based brick slip system. There is some caution that needs to be taken with this form of construction, but we'll explore why slightly later in this webinar. But the image on the right then, so that basically shows the design principles of this system. So similar to mechanically fixed systems, an insulation board is secured to a substrate using appropriate fixings. A layer of adhesive is then applied, which you can see here, which gives the bond to the brick slips. So this is essentially a bonding agent. And as seen again in the left-hand image, these are basically put on place similar to tiles that you would see at home. Now, this form of construction is typically associated with something like a living room wall to give a design feature, but actually it is used in external applications. One of the main reasons that this form of brick slip may be used is lower costs, where carrier rails and other materials are avoided. The image on the right probably shows an external wall insulation system. I'm sure some of you are probably thinking, well, why would you install brick slips over a wall that's brick already? Well, presumably this wall is a solid wall, doesn't have internal insulation, and therefore someone's applied an external wall insulation system and they've wanted to retain the masonry design by installing brick slips. So before we move on to some of the more modern forms of facade construction, let's take a quick look at render, which is something that I'm sure a lot of you are familiar with. So as seen in the left image, render provides quite a clean, smooth appearance, which can either be coloured from production or it can be painted once applied. It's quite a common finish to external walls in both dwellings and apartment blocks, and that's because it has several benefits, such as a nice clean appearance. It can also provide protective properties to the substrate beneath, and it can actually improve a building's thermal and acoustic performance as well, due to creating that additional layer. Now, something that's becoming more and more popular in the UK is external wall insulation systems, which we kind of briefly touched on in the last slide. So the image on the right basically shows a typical build-up with a render finish. So an adhesive is applied to a substrate, which will be the external wall. Beyond that, an insulation board is then applied, which will have mechanical fixings. And a reinforcement mesh will then be applied on top of that. So once the reinforcement mesh is applied, you'll then have a base coat of render, which is then completed by a thinner coat of render. So this is typically more popular in properties with solid walls due to a lack of existing insulation. However, people may want to improve the sort of general energy efficiency and thermal performance of their building by installing one of these systems. One of the key benefits, I suppose, is the ability to insulate external walls without losing internal floor space, which is often seen as quite a challenge when it comes to solid constructed walls. Obviously, if you insulated a wall from the inside, you would lose valuable sort of gross internal floor area. So this method basically enables insulation to be installed without requiring residents to vacate their properties and lose floor space. However, these systems can cause some issues, which I'm not going to touch base on now, but we'll get into that a little bit further in this presentation. So let's move on to some of the more modern forms of facade construction, and we'll start with curtain walling. So curtain walling is typically very common in the commercial sector. However, with businesses changing their workplace strategies following the pandemic, offices are more frequently being converted into resi, and these facades are often being retained to sort of maintain value for money. So curtain walling can typically be split into two different forms: unitized curtain walling, which you can see on the left, and stick curtain walling, which you can see on the right. So the left image shows unitized curtain wall system. This form of construction basically comprises of prefabricating larger sections of a curtain wall system known as units off-site, and then installing these pre-made units onto the building structure, typically via brackets that you'd see connected to the structural floor slabs. These facade systems are often bespoke in design as well, so they can suit various design preferences and building layouts, which is one of the reasons that they're commonly used. Stick curtain walling, on the other hand, which you can see in the right image, is delivered to site in pieces. So these are namely mullions, transoms, you can have spandrel panels and glazing units, which we'll get into in a bit more detail shortly. But once they're delivered to site, they're then constructed on site by specialist trades. So both systems have their advantages and disadvantages, which we're going to explore in the following slides. But looking at some of the key factors of curtain walling. So firstly, it is non-structural, so curtain walling systems typically support their own weight. The imposed loads, such as wind, for example, are transferred back into the primary structure of a building. And generally, one of the main advantages is that you can have all sorts of materials. So when we often think of curtain walling as large spans of glazing, but actually they can include a range of materials such as stone and metals. Let's have a look at unitized curtain walling first, and look at some of the advantages and disadvantages. So the image on the left shows a typical unitized panel. It's got glazing, but it also contains stone. As mentioned in the previous slide, it isn't just glazing with this type of facade. So, as mentioned, these panels are constructed off-site and delivered as completed panels, which only require lifting and fixing into position. So, apart from that, what are some of the main advantages? Well, you can get increased thermal performance from curtain walling from unitized panels. So, pre-made units can be factory sealed and insulated to a higher standard than individual components. You can also benefit from increased water tightness. So unitized curtain walls typically have better weather performance than other type of curtain walls, such as stick curtain walling, as they're manufactured in controlled environments using modern methods of construction. Another key benefit, which I also just mentioned, was that prefabricated panels can be installed quickly once they arrive on site. They'll be craned into position. They can be installed from the inside of a building. And typically the process is a lot quicker than other forms of facade construction. Another benefit, which is a cost-saving benefit, is that less skilled labour is typically required to install these on site. So, as previously mentioned, they're lifted into position, they're bolted into place using specially designed brackets, rather than being constructed in pieces, which would be the case with stick curtain walling. Another key reason is it can accommodate good structural movement. So pre-made units are often designed to flex and shift with a building structure, resulting in less sort of cracks or defects from structural movement. They also provide a very consistent appearance across a building facade. So, which a lot of people see as a key benefit. They want a nice, smooth, flush facade that sort of portrays one type of design, if you like. So these panels are very good for providing a good unitized, consistent appearance. And then last but not least, it does have good benefits in relation to fire, smoke and acoustic separation if constructed correctly. So unitized curtain walling panels can be manufactured with fire stopping and acoustic treatment sealed within the units, correctly installed from factory. So, as with any type of facade system, it does have some disadvantages. So let's have a look at what some of those are. So unitized curtain walling is typically more expensive than stick curtain walling due to the initial manufacturing costs. You also need to consider some increased time and planning off-site. So this is during the pre-construction period where you need to plan, you need to design, and the panels need to be manufactured. But of course, clever programming can allow for some overlap between design and construction. Another disadvantage is it does require greater upfront investment. Contractors may require advanced payments with this type of wall system. So typically a project that involves this system would follow a less standard or a slightly more complex payment process. Another disadvantage is they're harder to maintain. So repairs and maintenance may require external access, and in the event of failure, panels may need to be removed in full, which can obviously cause significant disruption to those using the building. Transport and delivery challenges are also another disadvantage. So panels can be large and transporting them can therefore be quite a challenge, especially where site access is limited or there is a lack of external space. And last but not least, as with anything in construction, improper installation can lead to misalignment issues and various defects, such as affecting the weather tightness of the system or the acoustic performance. So, as with everything, the quality of the outcome is only as good as the quality of the workmanship during the installation period. So moving on to the manufacturing installation process, this is just a quick slide really to show some of you the typical process of unitized curtain walling. So in the first photo on the left hand side, we see the production of curtain wall panels in a controlled factory environment. So panels are carefully put together with close attention to detail given to ensure that it's correctly sealed and that it achieves the design criteria. In the second image, so the middle image, you can see a typical delivery site. So panels are stored carefully in this instance to ensure they're not damaged in the transportation process, and then lifted into a storage position. So this form of construction really benefits sites with small storage areas, as whilst panels are large, they can be delivered in batches, often from a temporary storage yard located somewhere between the factory and the site, and then installed prior to the next delivery. So it enables a phased sort of delivery and installation approach rather than having to store a bulk of materials for the installation process. And then the final image, we see on-site installation. So this is a large sort of unitized glazed panel. As you can see, it's being lifted in via a crane, and workers inside the building then carefully place that into position, and someone will connect into the fixings. So let's move on to stick curtain walling and look at some of the key advantages that may sway building owners to use this form of construction. So one of the main advantages really is the lower initial costs during projects. So this form of curtain walling generally requires lower initial costs and lower upfront investment. As mentioned previously, materials are delivered to site in pieces and then installed together. So this can allow for a more flexible payment schedule, basically, with far lower advance payments if that's deemed required by the contractor. Another key advantage of this system is that overall stick curtain walling is considered less expensive than unitized systems as a whole sort of package. So whilst there are higher costs from the offset with unitized systems, these systems, stick curtain walling, typically requires less specialist equipment and manufacturing process involved throughout the production and installation process. Another reason why this is a good system to use in certain instances is that it's easier to maintain. So stick curtain walling, it's generally easier to maintain. Individual elements can be removed and replaced both internally and externally. So external access isn't always required, and the need to remove full panels and potentially have them replaced is omitted. Reason is design flexibility. So stick curtain walling is quite a traditional method that allows for custom adjustments and adaptations on site. So this makes it quite suitable for a wide range of building shapes, sizes, and design requirements. And then last but not least, lead-in times is quite an important factor. So typically this form of construction has a quicker lead-in time than unitized systems due to less complicated manufacturing processes. So for someone that wants to get the building on site as quick as possible, this is a more sort of advantage, a better system than unitized curtain walling. So now that we've looked through some of the advantages, let's have a look at some of the disadvantages. So starting off with the installation period. So stick curtain walling has a longer installation period on site. As mentioned, the individual elements are constructed piece by piece, so it takes a lot longer to install once it arrives on site than a unitized system. There are also some performance issues with stick curtain walling if quality of workmanship isn't up to scratch. So as with anything really, poor workmanship can result or will result in poor performance, which is a risk with this form of curtain walling. It does need specialist trades to install it. It's not the sort of work that a general builder or contractor can do. This type of curtain walling may also be more susceptible to water infiltration. So this point really follows on from the previous point on workmanship. If workmanship isn't up to the required standard, then weather protected properties of the system can be compromised. Again, as mentioned, it requires more skilled labour and may require scaffolding and other equipment to reach higher elevations. So typically that means that this system is more beneficial to low-rise buildings than higher-rise buildings. Although as seen in the image, it can still be installed to higher-rise buildings if this system is the preference. Moving on to some of the final sort of disadvantages then. Thermal performance is one of them. So good thermal performance can be harder to achieve than a unitized system. Again, this can be due to the quality of workmanship, but it's also due to less refined manufacturing processes. Last but not least, as mentioned, quite the opposite to the advantage of unitized curtain walling. Stick curtain walling does typically require an increased storage space on site. So, and it requires it to be installed over a longer installation period. So in this slide, we look at the installation process of stick curtain walling. So as mentioned previously, this type of curtain walling is delivered to site and then installed in individual pieces. So it's installed by specialist trades, as you can see by the left-hand image, opposed to curtain walling, which is installed from the inside of a building. Stick curtain walling is installed from the outside of a building. And the image that you can see here on the right is really quite a basic sketch of the various elements of stick curtain walling. So the word stick, as you might have guessed, refers to the horizontal transoms and vertical mullions that form sticks, and the remaining materials such as sort of spandrel panels and glass materials are then installed and fixed to that framing. So rain screen cladding, this is a type of cladding that's become very popular in the UK. It has been around for some time yet, but not as long as some of the other sort of traditional forms of construction. And it does come with a lot of advance. It does have a few benefits to it. So let's have a look at some of the benefits to this type of cladding. So it's lightweight and it's quicker to install. It can typically be installed quickly without disrupting the interior of a building as well, which can be of key benefit to a lot of building owners. Water damage protection is another a key benefit of this system. So an air cavity between the outer skin and the inner skin basically protects the building from water damage. And some of the other benefits of this system is improved thermal and acoustic performance. So there can be an insulation layer within, which is optional, but when you combine it with a rain screen cladding system, the thermal and acoustic performance of a building can improve quite significantly. So this can have quite a large benefit on a few things. It can benefit health, for example. It can benefit from environmental pollution, which is typically sort of diminished, and health issues derived from that can be reduced. And additionally, this system removes thermal bridges, which is quite important. Another reason that this system is quite commonly used is that it's durable. So an air cavity in the rain screen cladding provides a constant ventilation and therefore keeps the exterior cladding dry on the inside, which generally improves the durability of the system. Energy efficiency is also another key example of why this system is commonly used. So again, the air cavity behind the cladding can help the building stay cool in the summer and warm in the winter, which overall can save energy. Perhaps one of the most important reasons why this cladding is used is it has minimal maintenance. So rain screen cladding systems typically require little to no maintenance, especially if you choose a cladding material that can withstand adverse weather conditions, such as a high quality natural slate, for example. Then I guess the final reason that I wanted to summarise was reduced structural movement. So the air cavity within this system basically allows for maintaining a more stable temperature in the building envelope. So what does that mean? So it basically means that it prevents the risk of cracks and other structural issues. Since the structure is not subject to extreme temperature changes as a result of that cavity, it is less liable to suffer expansion or contraction movements. Then the final point on rain screen cladding, I guess let's just have a look at some of the disadvantages. So this form of walling is typically more expensive than other traditional forms of construction, such as masonry. So those on a budget may not favour this system over other forms. Performance can also be an issue. And again, sort of highlighting this point, it is really reliant on quality of workmanship. So as mentioned, a few times when summarising some of the previous systems that we've covered already, performance of the system is really only as good as those that install it on site. Repairs as well, so these can be complicated depending on the location. For example, an outer panel may require removal to inspect a defect, and if that defect has been witnessed at high level, such as an internal damage to the internal fabric, then works can be quite difficult to undertake just to sort of ascertain the extent of damage. Another disadvantage to this is actually the time it can take during the design period. So a good design will take increased research, it will need additional detailing, and it will need planning to ensure more planning than a traditional wall would typically require. It might also require increased inspections on site to monitor the quality, which is something that I would personally always recommend, and we'll get onto a few reasons as to why that is shortly. And then last but not least, whilst rain screen cladding has been around for quite some time now, it is only in recent sort of decades that it's become more popular, and therefore compared to some of the other forms and more traditional forms of facade construction, we haven't had the same amount of time to review it and for it to basically show up all the potential long-term weaknesses. So in the final slide for rain screen cladding then, I just wanted to show the typical sort of build-up of this. So in this slide, we see an example build-up of what a rain screen cladding system is. And that typically comprises of an inner substrate, which could be solid masonry or a sheathed steel frame. Attached to that would then be insulation. Again, this is optional, but a lot of the systems do contain it. This could be formed of materials such as mineral fibre, and the specification of that will really be determined based on required U values or sustainability targets. We then have the subconstruction to the outer layer itself. So here you see a bracketry system, basically. The image here shows it made out of steel, but it could also be made out of timber, which is something that was fairly commonly used in the past. And then finally, you get the rain screen panel itself. Now, in this image, it shows a glass rain screen panel, but a variety of materials can be used. So glass, aluminium, high pressure laminates are something that was quite common in the past. So there's a huge sort of array of materials that can be used for rain screen cladding, which gives it quite a lot of flexibility in its design and appearance. So now that we've kind of gone through some of the key facade systems that are in use, let's have a look at how long those systems last. So firstly, I always say it's important to consider the design life of a building in relation to these materials. So whilst buildings can typically last a very long time, on paper they generally have a service life of about 50 to 60 years. But of course that can vary depending on the form of construction. It's also quite important to consider manufacturing contractor warranties with these facade systems, as some repairs or maintenance may be covered by a guarantee. But looking at this table here, what I've tried to do is not necessarily just highlight the whole system itself and how long it lasts, but the individual materials that form those systems. So starting with brick, brick typically has a service life of about 150 years. Now that varies depending on the type of brick that's used. In practice, brick can last centuries, but everything has a service life. In terms of guarantees and warranties, this really does vary. There's not necessarily, to my knowledge, a sort of a blanket warranty for a brick wall system, but there are various protections that can that are established through contracts, for example. So the rectification period, there might be extended periods in contracts where sort of insurance backs warranties are in place for the building, and other bodies such as NHBC can provide sort of warranty or guarantee over these systems and the workmanship. Moving on, I guess, to some of the more modern forms of construction. Now, these systems are typically built up of various different materials. Looking at aluminium carrier rails, materials such as stainless steel, galvanized steel, the rain screen panels themselves and the insulation, cavity barriers, fire stopping that forms that build-up. Typically, that can have a service life of about 50 years, but the guarantee and warranty you get may be around 12 years. Now, note how I've highlighted gaskets, seals, and double glazed units in red. These typically have a service life of a lot less than the remaining facade. In these instances, it's typically about 25 years as a maximum. The reason I've highlighted that is I think it shows the importance of making sure that good maintenance is put in place. Just because you have a facade system that might have a service life of 50 years doesn't mean it's going to achieve that 50 years. Items such as gaskets and steel, seals, double glazed units, for example, do have a shorter service life, and therefore maintenance or replacement of those items can be required in order to achieve the sort of the general service life of the overall system. So let's have a look at some defects and then the importance of inspections and maintenance. So try to keep these slides pretty simple. I just want to show some of the key defects that we can that we see often as building surveyors in these various type of systems. So let's start off with masonry brick defects, which we sort of touch base on right at the start of the presentation. So external cracks are probably one of the most common sort of defects that people might come across when they're looking at a brick wall. Now, external cracks are often seen as quite a big issue or a cause of concern. This isn't necessarily always the case. Cracks can occur for a variety of reasons. So this could be thermal movement, it could be settlement, it could be subsidence, it could be cavity wall tie failure, for example, just to name a few. There is guidance out there on cracks to buildings. An example would be BRE Digest 251, which typically assesses cracks in low-rise buildings and dwellings, but the theory of that can be applied to higher-rise buildings. This basically states that any crack less than 5 millimeters in width can be filled and may not be of structural concern, but wider cracks than that may need further intervention. This could include helical wall ties, for example. It could include installing an expansion joint to deal with thermal movement, or in extreme cases, it might even involve reconstruction on the wall. So looking at the image on the right, then we have spalling brickwork, which is something that you might be familiar with. So spalling brickwork is another quite common defect, which can provide really quite a poor appearance. So spalling is usually caused by water, such as rain, snow, or even wet soil being absorbed into the brick. When the water freezes, it expands and damages the brick. And a process called the freeze-thaw cycle, generally that occurring over and over again can cause spalling of the brickwork. Now, this can be repaired by refacing bricks, but that's sort of another topic in its own right. What other masonry brick defects have we got then? So mortar deterioration is another quite common one. So brick mortar deterioration occurs really for a number of reasons. It can be the natural aging of the brick. It can be moisture in the joints, which are then impacted by the freeze and thaw cycle that we just touched base on. It could be exposure to weather and erosion, sort of just to name a few. Poor maintenance can also contribute towards this, as if mortar damage isn't repaired promptly, it can spread, which can then lead to water penetration issues. So if you see this on your building, it really is worth having it looked at by a surveyor who will determine whether it needs to be repointed or whether there's a wider issue. Oh, sorry, let me just go back. Fluorescent deposits is another common defect. Now, brick efflorescence is really a white powdery or sort of fluffy deposit of crystalline salts that form on the brickwork, mortar, or other porous building materials. So there's an argument to be made that efflorescent deposits isn't necessarily a defect, and it is just visible. It is just visual, but clearly it doesn't look bad, and it's important to residents that their building looks good. It's important to block managers that the building looks good. So efflorescent is typically something that you would see on newer construction. I think they say that in the first 72 hours, or after about 72 hours, moisture within that brickwork could make its way out to the sort of the outer leaf. So yeah, it's quite common during the construction period. Apart from that, though, it really is generally just visual, but a lot of people would want to have it cleaned. So let's have a look at brick slips. So you may have recalled that earlier on in this presentation, I gave an indication as to why bonded brick slip systems were considered quite dangerous. Well, there's quite a lot of study out there around this, actually. So there was a report that sort of caught my eye that I had a look over, and it was under the collaborative reporting for safer structures, and that looks at brick slips falling from height. So essentially, a reporter examined failures in brick slip systems, and he found that there were similar defects and occurrences across a few different projects. All of the projects were in the UK, and they were all constructed around the mid-2010s. It was found, and it's something that I've seen as well during surveys, that adhesive holding the brick slips to backing boards is failing, and the slips are then falling to the ground, which obviously cause considerable health and safety issues. So what are the possible causes of this occurring? So firstly, the adhesive layer could be applied too thin or inconsistently. The adhesion may also be inappropriate for use, so the wrong product could have been used. And I guess as a third point, brick slips are porous, which is something that's important to remember. So water penetration can make its way through to the back of the brick slip. And if an incorrect product has been used, that can reduce the effectiveness of the adhesive. Now, the CWCT, that's the Centre for Window and Glazing Technology, if I've got that right, also clearly requests in their guidance that extreme caution is exercised around the use of bonded brick slip connections. And that's for the reasons I've just set out. If a brick slip falls from height and hits someone at ground level, you know, the results can be pretty catastrophic, and nobody wants a claim against them or their company in that instance. So it's important that caution is taken. Now, these images kind of show that process. So in this left image, we can see brick slips that were bonded to the substrate. They've debonded and fallen from a height. The middle image shows sort of early debonding, where the brick slip system is starting to sort of bow and detach from the system. And again, the final sort of two images, the right-hand side one and the one on the middle, show this process that's already occurred. Moving on to render and external wall insulation system defects. So there's two things that I wanted to highlight from this slide. The first is the left image, which is something that I've seen called thin coat render. So this image, yeah, basically shows what appears to be a patch, a patchy sort of elevation of render. You may be able to see the square patch across the facade. In this instance, it was actually considered this could be due to the render being applied too thin over the external wall insulation system. And the result of that is that it looks really poor. Other render defects, just to summarise, could include cracking, which could be a result of incorrect application, structural movement, or moisture getting behind the render and blowing it. In the right image, we see missing fixings to insulation. So again, this is something that I really wanted to highlight, as it's something that should be looked out for carefully in the installation period. So the right image shows the process of an external wall insulation being installed. So note that some of the fixings, some of the panels have these sort of central fixings, and some of them don't have any fixings. If these are missed from the installation process, it can cause the insulation to deattach from the substrate beneath. Now, typically this would have a bonding agent behind it, but it shouldn't be relied upon. Fixings are there for a reason. If they're missed and renders applied to it, it can cause issues to that render applied on top. Moving on to some curtain wall defects then. So water ingress is probably one of the main defects associated with curtain walling. So there's 3 images here that all show where water penetration has affected the system and internal damage is caused as a result. So why does curtain walling leak? Well, there could be several reasons why a curtain walling system might leak. The first one could be poor installation. So if the curtain walling system isn't installed correctly, it may not be able to provide the sort of required level of protection against water ingress. So poorly installed flashing, sealant or sort of weather stripping can also contribute towards these leaks. Another reason could be insufficient or improper maintenance. So again, coming back to maintenance, it's really important that these systems are inspected and maintenance is undertaken regularly, as that's essential to ensure the ongoing function of the curtain wall system. So failure to carry out maintenance activities such as basic cleaning or replacing damaged components or seals can lead to water penetration. Another reason can be building movement or settlement. So movement or settlement of the building can cause stress on certain parts of the curtain walling system, leading to gaps or cracks that can allow water to enter. And as a final point, sort of defective materials. It's something that's maybe not as common nowadays, as the sort of manufacturing process is fairly quite diligent, but poor quality materials or defective materials that have been used in curtain walling system can lead to leaks. So this could include sort of cracks or holes or other damage that allows water to penetrate. And actually, I think a final point that I wanted to mention on this would be blocked drainage channels. So curtain walling can be drained, and blocked drainage channels can prevent water from properly draining from the curtain walling system, which can lead to water buildup and potential leaks. So it's important to ensure that drainage channels are unblocked and free of debris. That will ensure that there's basically efficient flow of water away from the system. So regular inspections and regular maintenance can help prevent these blockages and ensure the ongoing function basically of the system. Now, I chose these images for kind of a number of reasons, but really this image on the right here is something that I wanted to make an example of. So in residential properties, curtain walling may be finished with an interior lining such as plasterboard and metsec. Typically that can be the case, but that is the case with commercial as well. So in this image, we can see that there is no internal lining. Now, this could have been spotted during the construction period. It could have been that the internal lining was then removed to expose the extent of water ingress. But what I'm trying to get across is that leaks may not be seen right away, as the lining of this system may conceal the severity of the leak. So, you know, that can result in increased damage and sort of cost to repair. So it's really important when this system is installed that someone is reviewing the process and they're making sure that it's being installed correctly and that it's sealed. Yes, curtain walling systems are unitized curtain walling systems, are put together off-site and then put in place, but often they may need to be sealed at the joints with a mastic, and if that's not done correctly, then water can get through the system. What are some of the other defects? Gaskets, and so shrunken gaskets, dislodged gaskets are other common issues. So let's take a look at the left image to start off with. So this shows a shrunken gasket. A lot of people say this is kind of part and parcel of curtain walling, as gaskets do typically shrink over age, but there are a number of other factors that can contribute towards the shrinkage of gaskets, which can then result in water infiltration. The first one being UV radiation. So constant exposure to sunlight can cause gaskets to shrink, especially at the corners, as seen in this image here. Freeze and thaw cycles again can play a part in this, so that can cause gaskets to shrink and crack. Improper installation, coming back again to the importance of making sure that you've got the right people on the job and that they're installing it correctly, can cause issues with shrunken gaskets if they're not properly engaged or installed or centered. And I guess finally, a lack of maintenance, again coming back to maintenance. Gaskets may not be properly maintained, and if they're not, they can shrink and they can crack. So looking at the right-hand image, then we see a dislodged gasket, which is something that I spotted to a stick curtain walling system a couple of weeks ago. So gaskets and curtain walls can become dislodged, and this can be due to a number of reasons. Again, age can play a part in this. So over time, the elastic material in the gasket can dry out. That can cause it to shrink and it can crack. UV radiation and the freeze-thaw cycle can also play a part on that. Improper installation and maintenance, again, highlighting those points, that can cause these gaskets to dislodge. If the window hardware and locking mechanisms aren't adjusted properly during installation, the gaskets may not be compressed enough. If the opener wall, vents in the curtain wall system are not maintained annually, then those gaskets can deteriorate and become misaligned. So again, the main things really, making sure that it's installed correctly on site and making sure that it's regularly inspected and maintained can identify these issues early and stop issues amounting into sort of larger, more costly repairs. So let's have a look at rain screen cladding defects. So a common, the left image shows the distortion of high pressure laminate panels. So a common method of installing these HPL panels is to use a rivet fixing. Basically, a central fixing provides the gravitational loads, whilst perimeter fixings restrict movement from external factors such as the wind. But the perimeter fixings need to be installed in a way that it allows that panel to move as a result of thermal and moisture changes. Otherwise, there's a risk of distortion, which can damage them or pull them out of place. So essentially, that's what we can see in the left-hand image here. Another example could be an assumed lack of support. So the right image was taken from a recent survey in which corten cladding panels have been installed. So the panels appeared secure. However, when you managed to get a grip on them, they were quite flexible when pressure was applied. So we suspected that this might be due to a lack of intermediate supports, which would otherwise hold the panel in a better position and create a flush finish. So both of these issues really highlight the importance of ensuring that systems are not only correctly specified, but they're also inspected regularly during construction to ensure errors are avoided. A couple other sort of defects associated with rain screen cladding. So in the left image, we show some timber rain screen cladding, which appears to be poorly weathered. On the surface of it, it may look like it's decaying. A lot of people may argue that weathering of timber is part of the natural process, but to me, there's no denying that it can look poor. And actually, from my experience, when I've worked with clients that have picked out a particular sort of type of timber for their cladding, they typically look at what it looks like when it's just installed and not what it looks like when it weathers. So it is always important when you're choosing this type of cladding or material to consider not just what it's going to look like when it's been installed, but also what's it going to look like in 5, 10, 20 years time. And a final defect of rain screen cladding, if you take a look at the image on the right, it was taken from an intrusive inspection and showed that there was no provision for drainage, which had resulted in quite significant water ingress internally. So, as mentioned previously, rain screen cladding needs to be designed for water management, and where water when water can run down the cavity of a facade, it requires the correct design to ensure that water can discharge at appropriate positions. So again, you can consider this as a design defect or an installation defect, but either way, it's something that needs to be considered right from the start of the process and monitored throughout. So now that we've looked at some of the sort of common defects associated with facade systems, let's have a look at how often inspections should be undertaken. So the British Standards Institution, or BSI for short, published BS 8210, which is the Facilities Maintenance Management Code of Practice. That came out in October 2020. So this standard is really about managing maintenance, not actually about carrying it out. So it basically sets out that inspections should be undertaken in the sort of the following sort of stages. So Firstly, routine inspections. So routine inspections by a building management team should be undertaken throughout the annual period to determine whether specialist inspections are required. So this approach, just by taking routine sort of visual checks over your building's facade, can help identify defects as early as possible, and it can allow for intervention before more serious issues arise. So residents and other building owners should also be consulted regularly to determine whether defects are present to areas less accessible, such as private apartments. So internal cracks or damp, for example, could be due to facade elements failing, and knowing these issues exist as soon as possible can avoid more costly and disruptive rectification works. Then summarises what we'd call general inspections. So these are typically general, non-intrusive inspections which could be undertaken or should be undertaken on an annual basis. So this could be part of an annual planned preventative maintenance survey or a general buildings condition assessment. So these inspections are the ones that should really be undertaken by qualified, experienced professionals who will be able to identify defects and provide a suitable remediation methodology. It's important to consider the type of inspection that might be required. So drones or mobile elevated work platforms may be needed to get a closer visual access to the facade, something that may not be possible as part of routine day-to-day visual inspections. And then finally, detailed inspections. So these should be undertaken no less than once every 3 years. So these should be undertaken by specialist people who are experienced in assessing the facade in question. So under more detailed inspections, more intrusive works may be required. So this could involve removing a rain screen cladding panel, for example, to assess the non-visual elements of the facade, such as the support structure and the fire stopping. So this is really the process that I and a lot of others would recommend is put in place. Routine inspections throughout the year by the building management team, and regularly consulting residents to ensure that there's no problems they're experiencing that could be a result of facade failure. General inspections once a year by a qualified professional, visual, non-intrusive, to understand whether the system's failing and to allow budgets and maintenance programs to be updated. And then detailed inspections involving removing panels, looking inside a brick wall using a boroscope, for example, if a defect has been identified. Yes, and a final tip actually. So considering the timing of your inspections is quite important. In my view, it is always wise to undertake annual inspections, probably around about the sort of spring, early summertime. That can identify, if any defects are identified, it enables them to be made good during the winter. Before the winter, as obviously during the winter the facade may be susceptible to more sort of extreme weather conditions, and therefore water penetration could result in sort of increased damage. By undertaking inspections during the sort of spring period as well, any defects that have arisen during the winter period can be identified early and then rectified before the next winter period. So let's just summarise why undertaking routine inspections is so important. So, as mentioned previously, building owners and those responsible for the management have a legal duty to ensure their building is safe. If injury or damage is caused to visitors, occupiers, neighbours, third parties of the property, for example, by part of the facade falling, such as a bonded brick slip, then liability can arise. So it's obviously important to ensure that inspections are undertaken at periodic intervals to ensure defects are identified and dealt with before they escalate. So what else? So the regular inspection of a building's facade is obviously a key control measure to reduce the risks of these minor defects turning into major defects, which can result in reducing unnecessary expenditure. The longevity of a building is also something that can be influenced by routine inspections. So undertaking routine inspections can help prolong the lifespan of your building's facade. Also supports enhanced safety and good health and safety measures. So, as mentioned previously, this isn't just about reducing the risk of building owners, managers or residents occupying the buildings. It's also about reducing the risk to the public and to neighbouring properties. As a final point, I guess, property value and aesthetics is something that's obviously important to all of you. So conducting routine inspections can help identify defects very early. Defects look bad. They can affect the value of a property. They can make it look poor, which could put off potential buyers. It might result in tenants feeling that their building isn't being maintained very well and therefore moving out. So all of these reasons are really some of the sort of key summary points of why conducting routine inspections is so important. And preventative maintenance. So this is quite a large topic, and there's quite sort of conflicting views as to what sort of maintenance regime should be adopted. So the RICS have issued a professional standard for PPMs, and this applies to both commercial and residential buildings. So it was dated 2022 and it came effective in April 2022. Two of our own directors actually were part of the working group for this document. So the RICS describes a PPM as maintenance that is performed purposely and regularly to keep the structure and fabric, facilities, plant and equipment of a building in satisfactory operating condition. So what are the benefits of this, and why is it important? Well, the first one is to extend the asset's lifespan. So planning maintenance and undertaking maintenance before an element fails can increase the overall lifespan of that element. It's also important for health and safety risks. So, you know, some of those that we've seen in the previous slides could be managed or avoided if planned maintenance was put in place. It also allows for better budget management, which I'm sure a lot of you are familiar with. It allows for the allocation of service charge more efficiently as well. Increased resident satisfaction is another thing that I think is an important part of planned preventative maintenance. So it can result in lower disruption. Major works can be avoided. Residents can be given a heads up well in advance of the works that are likely going to be undertaken that year. Obviously, that can result in lower disruption for residents living in the building. Lower maintenance costs again. So, you know, PPMs can help reduce project durations and cost overruns. It can result in a decrease in funds spent on maintenance, some of which could potentially not be service charge recoverable. I think as a final point, because of that, there is an argument to be made that planned preventative maintenance can result in an improved return on investment. So in the final sort of section of this presentation, I'm just going to touch base on procuring repairs and maintenance. So we're going to look at some of the best practice tips and processes to follow to ensure that facade repair works, maintenance works, or reinstatement works are successful. So let's look at the pre-commencement stage and split this out. So we'll take a basic scenario, for example. Your facade has an issue. Through conducting a general inspection, some defects have been identified which require rectification work. So these could be cracks, it could be water intrusion, it could be dislodged elements such as gaskets or seals, which we've explored. So in my view, I always say that the success of a project is established during the pre-commencement stage. And for me, that can be split into 4 chronological phases. The first one being the investigation, analysis and reporting stage. So during this first stage, it's important to determine what further investigations are required. So a defect may have been established through a basic visual inspection from ground level. However, more detailed inspections might be undertaken, such as intrusive inspections or removing panels. And that's all there to try and analyse the full extent of the issue and report on remedial solutions. So the investigation phase, to me, should follow quite a classic method, and that's gathering available data on the building. So that could be existing reports and drawings that detail the construction and the materials used. It should consider the inspection methodology required? So is it purely visual? Do you need to use advanced digital imaging? Are exploratory works required? Do you need a drone, for example? It should also analyse the information that's been obtained, and it should reach a logical, consistent conclusion. And that conclusion should recommend the most suitable repair methodology through a professional reporting procedure. The second stage would be documentation preparation. So this stage basically sees the documentation prepared by the employer's team. And that team should be chosen based on their suitability. So are they experienced in this type of work? Do they have the right expertise? Do they know the type of facade system that you have on your building? Following, the establishment of all of those defects and the underlying causes, a detailed pack of information should be prepared prior to approaching the market. So a good successful project should see good quality workmanship addressing issues correctly and at source, and those should be addressed on time and on budget. And a well-prepared and robust pack of information is really key to achieving that. So the documentation should be clear in setting out which works have been designed and precisely what the contractor is required to undertake and price. It should identify any areas where a contractor's design portion is required to avoid any misunderstandings. I personally was always taught to follow what I was called the 4 C's. And that's clear, correct, complete, and concise. And if you follow that, then you should have quite a robust pack of information. Following that, you should now be ready to commence into the third stage, which would be tendering a negotiation. So this involves tendering the works through the market and selecting a suitable contractor. So your professional team should be able to identify a list of contractors that are deemed suitable for undertaking these works. The contractors should be experienced in working on the type of facade system that you have. They should have a good reputation and they should be able to demonstrate their understanding and their suitability of the project. This can be supported by a pre-qualification questionnaire, for example. It's also very important to conduct checks on the stability of a contractor to understand whether they're at risk of collapse or have bad debt. I was recently told by a facade engineer at a company called Wintech that the average life expectancy of a facade subcontractor is 7 years. Now, I'm not sure whether that's correct, and I can't confirm, the original source of that. But what that does say is that 7 years for a contractor really isn't very much time for a contractor to set themselves up, market themselves, win work and deliver work. They may only be able to undertake a few projects in that period. So it just goes to show that a lot of contractors and subcontractors can run into issues when it comes to this sort of work if they're not set up for the job. And it's too easy nowadays for companies to close door and reopen elsewhere. So it's really important that you undertake a check of who you're employing or who you're going to be asking to do this work, and make sure that they're financially stable and they've got a good reputation. I guess in addition to that, before issuing invitations to tender, the employee's requirements and works information should be airtight. So tender returns will typically only be as good as the information a contractor has based it on. And then the final point, we get into the contractor's appointment stage. So it's always important that any works are appointed under a correct form of contract, and this could be, the JCT suite or the NEC suite of contracts. So, these are typically there and they're designed to ensure that there's a clear contractual agreement between both parties and that risks are mitigated where possible. So standard forms of contract without amendments are typically preferable, but in practice this is rare. Often you get bespoke forms of contracts or long and often complicated schedules of amendments or schedules of derogations that are there to try and reduce people's liabilities, in which case having a legal advisor to look over those is always important. So yeah, it is generally very important that your professional team and legal team review any of these sort of schedules or lists of clarifications and derogations to ensure that you're not left open to the risks or any sort of key exclusions. I always recommend to clients as well that you have a hierarchy of documents referenced in the contract documents. So this basically ensures that both parties are aware of which document takes priority over others, as there can often be clashes between the employer's requirements and the contractor's proposals, for example. I guess throughout that whole pre-commencement period, I think keeping residents informed is really important. Now, I've been on the other side of this, living in a flat block before where works have had to be undertaken, and I can tell you how frustrating it is when no one is up to date or really understands what's happening, when it's happening, or why it's happening. So keeping residents informed throughout this process will no doubt, contribute towards their satisfaction and just, provide a generally good relationship between the block manager and the residents living within a block. So let's move on to the construction phase. So an update to the scenario that we put forward before. So the required works have been identified, a specification for repair works has been established, and following a competitive tender process, an experienced contractor has been appointed under a suitable form of contract to undertake the works, and these are ready to start on site. So for me, good project management and some general considerations will result in successful project delivery. So with many cladding systems, it's important to note that you often have one chance to get it right. Poor workmanship can quickly be concealed during the construction process. And unless it's spotted during that period, it may not be apparent that there's a defect until a more serious issue arises at a later date, such as water ingress. Now, what are some of the sort of tips or considerations that you can make during the construction stage? Well, novation's a common one, and there are some benefits to novating your design team to the contractor. So in the context of ensuring that facade works are completed to the correct standard, novating an architect or a facade engineer, for example, can ensure that you as a client has a good set of eyes at the other side of the table. So that can ensure that quality requirements are being followed, both in contractor's design and site installation. Ensuring that works are monitored regularly by a competent person. So, regular monitoring will ensure the correct installation process is being followed and works are being undertaken in accordance with the specification. It can enable defects to be identified before they become an issue. Ensuring clear communication lines are established, and this is both between the employer and stakeholders and the employer and the contractor. Well, this is vitally important in my view, not only to keep residents or other stakeholders up to date on progress and to minimise disruption, but good communication between a contractor and employer, even if that's through an employer's agent or a contract administrator, should ensure that issues are mutually understood, and that plans can be put in place to rectify any issues that have buy-in from all parties without delay. Other consideration is the timing. So the timing of scheduling key site visits and documenting, the works being undertaken. So inspections should really be scheduled at key milestones. It's no good having an engineer or an architect turn up to site to review the quality of work, which is now concealed. So it's important to make sure that inspections align with the construction programme. It's also important to understand the works being undertaken are documented. You should have photographic evidence of the system being put together, as both parties might need to rely on that in the future for one reason or another. So complying with the terms of the contract. So this might sound like a really obvious one, and obviously it should go without saying that both parties should always stick to the terms of the contract. Not only can this avoid disputes, but it can protect you in the event of a dispute where you may have complied with the contract, but a contractor hasn't. So construction projects go wrong. People have disputes over variations or loss and expense in the event of delays. So it's important to make sure that you're complying with the terms of the contract, but also ensuring that someone else, like a contract administrator or the employer's agent, is doing their job properly, and making sure that both parties are complying with the terms of the contract. And as a final point, so ensuring that relevant tests are completed at completion. An example of this could be CWC water testing. So it's really important to make sure that these tests are there and that they're undertaken at the right times. And water testing is a really good example. That will confirm whether a facade is watertight or not. I had a project a couple of years ago where we were reinstating a unitized curtain walling system further to a sort of a partial demolition project. And visually, when inspecting that system, everything looked good. The mastic looked like it was installed correctly, but upon CWCT water testing, it was evident that it wasn't performing as it should, and that additional works needed to be undertaken to make that good. So you shouldn't always rely on your eyes, basically. There's testing there for a reason, and it's important that that's undertaken at the right time. And then the final slide of this, we just want to have a look at the post-completion stage. So at this stage, it's really important to ensure that all relevant consents and sign-offs are achieved. And this isn't just building control and planning, for example. This could be architects via statements of compliance. It could be your facade engineer confirming and providing a signed written statement that everything's been undertaken and installed in accordance with the specification. It's also important to ensure that CDM duties are discharged. And what I really want to focus on here is the supply of a comprehensive health and safety file. So that should be prepared by a suitable person with the correct expertise. Obtaining detailed and complete O&Ms. Again, some of this is very obvious, but you'd be surprised how often we look over O&Ms and they're not up to scratch. They don't have the required amount of detail, or maybe they're not even in place. So actually not just obtaining detailed O&Ms, but storing them correctly, whether that's an older school way on hard copies, or whether it's on file or in a data room. But detailed O&M should always be provided, and that should contain all information on the system being installed and include future maintenance requirements. Guarantees and collateral warranties is another really important one. These should be in place and fully signed. Again, you'd probably be surprised if I told you how often I see guarantees and collateral warranties that haven't been executed, or they haven't been signed by the correct party. In some instances, a guarantee or a warranty might be caveated and state, unless it's been fully signed by a director or a relevant person, then it doesn't apply, or it's not, it doesn't work. So making sure that these are signed properly by the right people and that they're in place and that they're watertight is important. So furthermore, conducting inspections during and at expiry of the rectification period is important. So inspections should be undertaken during the rectification period, both during that period and at expiry, to ensure that any defects that are visible or apparent can be raised and addressed promptly and within the contractor's liable period before their retention is released. I always believe that conducting lessons learned is of utmost importance. So, and that should involve all parties, including the contractor. This enables any errors to be identified and discussed so that they can be avoided in future work. So a lessons learned exercise is something that, I think everyone should adopt at the end of every project. As a final point, always consider the future requirements in terms of maintenance of your facade. Ensure that the PPMs or your maintenance regime is up to date, and that budgets are in place and up to date to account for any sort of new materials or systems that may have been installed as part of these repair or rectification works, which could otherwise put your PPM sort of schedule or budget out of place. And really, that summarises today's presentation, which I do hope you found helpful and it passed on some sort of basic knowledge to you. I think I'm now passing back over to Vicky, am I, to see if there's any questions?
We've got no questions at the moment, actually. So yeah, I think we can finish up there. Thank you very much for your time, Dan. That was really insightful. And thank you everyone for joining us this afternoon. As I said, the recording will be available if anyone would like to watch that back, or they couldn't join us live on the News on the Block YouTube channel. And if you would like a copy of the slides from today, then please do drop me an email, and myself or Watts will be able to provide that for you. Otherwise, yep, thank you very much. Enjoy the rest of your day, everyone. Thank you again, Dan. I'll speak to you soon.
Yes, thank you, Vicky, and thank you everyone for joining. So details are here at the end. You've got my details at the start. Vicky, I will send you the presentation slides today so that you can get those sent out. If anyone has any queries, please do not hesitate to contact us. We'll obviously address those. We're happy to come and sit down with you and have a run through everything as well. So just let us know.
Great. Thank you very much, Dan. Have a good day.
Brilliant. Thank you all.
Bye.